Swayam Prabha. Digital India. Educated India.
Hello everybody, welcome to my course that reactive intermediates, carbenes and nitrenes. We have already studied all about carbenes and we have started about nitrenes. For nitrene already we have discussed about its electronic configuration, hybridizations etc. So, today we will discuss about varieties of reactions that is associated with nitrenes. As per example, okay. So, reactions of nitrenes. So, basically we will discuss the cycloaddition of nitrenes similar like carbenes, okay. And in case of cycloadditions we will discuss the cycloadditions with alkynes, alkenes, mostly with alkenes and then with alkynes with the nitrenes. Then we will discuss about various type of insertion reaction, okay. It could be intramolecular, it could be intermolecular reactions for different type of nitrenes, and finally we will discuss lot of rearrangement reactions, okay. As per example, Hofmann rearrangement, Lawson rearrangements, Mead, Curtius, like different type of rearrangements with nitrenes we will discuss, okay. So, next we will see that the first topic of our nitrenes reactions, that is the cycloaddition. Okay. So, if you see in case of cycloaddition, this is similar like carbenes, like nitrenes is generally electrophilic in nature. Okay. So, mostly it reacts with various type of alkenes which are in general electron rich, that reacts very nicely with different type of nitrenes, as these nitrenes are in general electron deficient. Okay. So, what they will do in case of triplet nitrene and in case of singlet nitrenes, we have seen in case of carbenes that if the carbenes are singlet in nature, they generally react with the alkenes in concerted manner, okay. And if the carbenes are triplet in nature, then they generally react in stepwise manner. We have seen those things. So, in case of nitrenes also it is in similar way they will react, that in case of these nitrenes, if it is a singlet nitrene, they will react in concerted manner. So, the retention of stereochemistry of the alkenes will occur, whereas if the nitrenes are triplet in nature, then they will react in stepwise manner, and of course, you will get the mixture of cis trans products. Okay. So, what we have seen that in case of addition to alkene, okay. So, nitrenes addition to alkene, if we see that if it is singlet nitrene, then it will works like a in a concerted manner, okay. Whereas, if the nitrenes is triplet nitrene, then they will give the in a stepwise manner. So, stepwise manner, basically these triplet nitrenes, they are actually acting like a diradical way. So, they will react with the alkenes in a stepwise manner. We have discussed these mechanisms, how this stepwise manner or how these concerted reactions are going through in case of carbene in a very detailed way. So, here we will not discuss those things in very detailed way, but it is also in similar mode of action. This is also going via concerted in case of singlet nitrine, and in case of triplet nitrine it is going like a stepwise manner. Okay. So, as per example, if we see that if we take okay, so this is the E olefin. Okay. If we take with a singlet nitrine, after this addition reaction, this cycloaddition reactions, this is a 1 to cycloaddition type. So, this will give this type of aziridine product. Okay. Similarly, if this is cis, then you will get the cis product. Okay. So, if the geometry is Z for this olefin, you will get cis product. So, in general the olefin and the corresponding nitrine, they will react in a concerted manner. Okay. So, they will react in concerted manner. So, the geometry is here retaining, that means retention of this stereochemistry is happening. Okay. So, this is also in similar like carbene. Now, what we will see that how different type of alkenes are actually reacting with various type of nitrines, okay, or nitrine type of intermediates, reactive intermediates. As per example, if we take this olefin, this terminal olefin, okay, and if we take this aryl sulfonyl iminoiodinane, this is like paratoluene sulfonyl. So, in presence of copper triplet, okay, so that will generate from this one, this is the corresponding arene sulfonyl iminoiodinane, here it is phenyl sulfonyl rather, this is the iodinane that is attached with this paratoluene sulfonyl iodinane actually. So, if this one will react with this corresponding olefin, so this will give the aziridine ring, this one is corresponding okay. So, this will be the end product fine. Similar way, if we take this olefin cyclohexene here, then similarly in presence of this sulfonyl iminoiodinane, that is let us say we have taken NSO2 toluene, then again in presence of copper triplet. Okay. So, this will generate from here, this will generate the corresponding, or in this case here this will generate the corresponding nitrine, and that eventually will give the end product, sorry, the corresponding aziridine ring. Okay. So, these are the way that this 1,2 cycloaddition is happening with various type of nitrate species with olefins. Now, we will see not only this type of alkenes, rather if the nitrines that generates from various alkynyl and allyl azides, what will be the consequences. Okay. So, let us say if this nitrine that is associated with the corresponding olefin in a same molecule, that means the reaction is going to happen in intramolecular way, then what will happen? Obviously, product that is coming from these reactions are highly strained compounds. Okay. As per example, if we take the nitrines from various alkynyl or allyl azides, okay, then what will happen? First, let us say we have taken this vinyl azide compound and we have under photolytic condition, then this will create this corresponding nitrene. Okay. Now, this nitrene will can give two different product. As per example, if this will migrate over here, then actually this type of highly strained ring will form, 3-member nitrogen containing ring will form. Okay. So, this will generate this type of as a ring type of compounds actually. So, okay. Or another option is also there, that is not only this one, rather this group that can also migrate. Okay. So, once this will generate like this, so this can also migrate. Okay. So, what will form the end product? That will be the corresponding rearranged product, that is nothing but this type of product. Okay. So, in this case what we will get, that finally this will be the product, that when this not only this double bond, rather this R group that will migrate over here, then it will give finally this type of, like in case of, we have seen that in case of carbenes it gives the corresponding ketene type of compounds. So, here also you will get similar analogous compound. Okay. Next, what we will see, that if we take the corresponding allyl azides. Okay. So, let us say we have taken this allyl azide for the precursor of the corresponding nitrene. Now, again under photolytic condition, so this will give the corresponding nitrene. Okay. Now, once this nitrene generated, then now this can nicely give the corresponding cycloaddition product, and that is this highly strained compound, where this 3-member ring, 3-member this aziridine ring, 2 aziridine rings are fused. Okay. So, this is highly strained, because if you see this nitrogen, that is actually getting addition in this olefin, and once it is happening, it is actually giving this 2 strained aziridine ring, okay, that is fused together to finally give this product. Okay. In similar mode, like nitrines, not only with this different type of alkenes, or it is reacting, it can again react in 1,2 addition mode to 1,3 dienes also. So, what I am meaning, that let us say you have 1,3 dienes. So, in that case what will be the end product? As per example, let us say we have taken this nitrene and the corresponding 1,3 diene. Okay. So, if we take this now, in this case, if it reacts with the corresponding nitrines, it actually reacts with the only the 1-2 additions will happen. That means, this will only react with one of them. As per we have seen that in case of carbenes also it is reacting in this similar mode of fashion. So, here also it will react in similar way, that it will only react with one of this olefin. Okay. So, finally, what will be the, in this case the product will be, okay, and now under heating condition. Okay. So, in this case what will give, this will actually give the corresponding dihydropyrrole moiety by the certain rearrangement. Okay. So, this will overall give this dihydropyrrole moiety. Okay. So, this is the way that nitrene can react with various type of olefins, okay, where we have seen that mostly it is also behaving in similar fashion like carbenes. Next we will see that how these nitrenes that is going to react with various alkynes. Okay. So, we will see now addition to alkynes. So, we have seen in case of carbenes how they are reacting with alkynes. Okay. So, in similar way here nitrenes, that is also electron deficient species, and that is also similar way that is going to react with the alkynes. As per example, we will see here that first we will take these N-aminothalimide type of species, which after oxidation will give the corresponding nitrene. This N-aminothalimide, this derivative in presence of oxidant. Okay. So, this can react with this alkyne to give the corresponding azyrene ring. Okay. So, once it is having this, then obviously I am not writing the whole thing. So, basically we can write here PHTH in spite of writing the whole thing, and then we have seen that this compound is not stable, because this is basically, if you see nitrogens are having 2 lone pairs, and so in this case this is getting anti-aromatic. Okay. So, if this is becomes anti-aromatic, then what will happen? This will again rearrange itself. Okay. So, due to that rearrangement, okay, what will happen? That this azyrene ring will convert into its analog. So, what will happen here? That this azyrene ring will actually, this thalimide group will migrate over here, and this one will shift. So, overall the product will be, in this case, okay. So, in this case what we will get? We will get the initial product in such a way that this is not stable product, because this is somewhat anti-aromatic, and once it becomes anti-aromatic it loses its stability, and after the rearrangement we are getting this another rearranged azyrene ring, and that is nothing but this particular product. Okay. So, what will happen if that way we are generating, like let us say as azides we have taken and alkyne we have taken. Okay. So, under thermal condition it should give the corresponding nitrene, and then that cycloadditions type reaction should occur. But what actually in many cases it has been found that the reactions of azides and alkynes are so facile that in spite of giving that nitrene, this azide, which is actually a 1,3 dipole, also we can consider them as 1,3 dipole, that can react nicely with the alkynes in a 3+2 cycloadditions mode. So, what I am meaning that if we have, let us say this alkyne, now this can have the corresponding okay. This is the azide. So, this is your alkyne, this is the alkyne part, okay, and this is the azide part. Now, if you see that this is nothing but 1,3 dipole and this is the alkyne. Now, this can nicely goes in 3+2 cycloaddition mode. That means that this can attack like this. Okay. So, under thermal conditions, before giving the nitrene species, this can rapidly convert to the corresponding 1,2,3 triazole derivative. That is another very important heterocyclic, highly enriched, nitrogen enriched heterocycle, that is called 1,2,3 triazole moiety, that we will get. So, what will be the product then? The product will be okay. So, here this and then CO2 and here CO2. Okay. So, these are the corresponding 1, 2, 3 triazole derivative. Okay. So, in this case what we have found, in spite of generating the nitrene, rather this 1,3 dipole, here it is azide, that is nicely going through 3+2 cycloadditions, and which finally gives that without giving the this nitrene based cycloaddition product, rather it is giving the corresponding 1, 2, 3 triazole derivative. Okay. So, overall this is another type of reactions that is actually coming not through nitrene, rather its precursor, that is without generating the nitrene species, that is giving this different type of reactions. Okay. Only what is the reasons, that in this case that this 1,3 dipole, that azides, that reacts very fast under these thermal conditions with the alkynes, so that this triazole moiety can generate. Okay. Now, what will happen if we take this type of nitrines, and what will happen when they will react with the corresponding arenes? So, what I am meaning to say, that addition to arenes. As per example, this nitrene, that can also react with very neutral, that is benzene. Okay. So, this will generate, if it reacts with the corresponding benzene, the, as per example, if we take ethoxycarbonyl nitrene here, okay. So, in this case this will generate this type of 3 member aziridine type of ring. Okay. Then the corresponding electrocyclic ring opening will happen in this way. Okay. Once this electrocyclic ring opening will happen, then this will give the 7 membered azipine ring. Okay. So, okay. So, 1, 2, 3, 4, 5, 6, 7. Okay. So, next okay. So, this is called azipine ring. Okay. So, 7 member nitrogen containing these compounds, this is the azipine ring. Okay. So, now once this is having, then what will happen? Then this compound actually coming through this first this 1 2 cycloadditions followed by this electrocyclic ring opening. So, electrocyclic ring opening, okay, that leads to this azipine ring. But when this nitrene is associated with aryl sulfonyl group, then it has been found that not only this type of aziridination is forming, rather in similar way like here it has formed that in this one, if in presence of acid, what happens actually, that in presence of acids this will give the corresponding aniline derivative. So, the protonations will occur here, and once the protonations will occur here, this ring will open, and after that deprotonations will give the corresponding aniline derivative. Okay. So, NHCO2 ET in presence of acid, but if you have this NSA2 air, in that case it is not even going through this, you do not need even acid. In absence of acids also, this ring that will without going through this electrocyclic ring opening, rather as this due to the presence of this sulfonamide group, this can easily open this 3 member ring in without even in presence of acids. So, that finally you will get this aniline type of derivatives, that is very facile in case of these nitrenes that is associated with this aryl sulfonyl group. In that case, this type of aniline derivatives are predominant because of the stability of this anion in presence of SO2 air is very good. Okay. Thank you very much.